What up, dogs? Mr. Allen here, simplifying some radical expressions with variables. And I got a few different types of examples. No coefficients out front. We got some stuff out front. All right, so let's start with the first one up here. Square root of 32, x to the 7th, y to the 8th. What do we do? Well, we're looking for pairs because it's a square root. If it were a cube root or a fourth root, we'd be looking for groups of 3, groups of 4, so on and so forth. We'll do that in another video. Here, we're looking for pairs. All right. So 32. Well, I can break that down into prime factors. I'm going to go with 2 and 16. If you notice, you can stop here, take the square root of 16, it's 4, take it out. But if you don't always notice that, I'm going to run it through the entire thing right now. So I'm going to get 2 and 8, 2 and 4, 2 and 2. Now I'm going to circle all my pairs of 2s. Doesn't matter which pairs you go with. I'll go with these two and these two. So that means I'm going to have 2 times 2, which is 4, coming out. 2 gets left inside. All right. So I'm going to start working out my final answer right here with a 4. But that 2, I got to remember to put that back in. Sometimes I even jot it down like up here, just as a little note to myself, like, hey, there's a 2 that's got to go in there. Okay, and I'll do the same with the other variables. Now my x's. I have x to the 7th power. So how many pairs of x's can I take out? Well, at the start, if it helps, you can write them all out. I'll write out 7 x's. We got 1, whoop, 2, 3, 4, 5, 6, 7. I got a pair, 2, 3 pairs, and 1 left over. So I'll have x to the 3rd power with an x left over. And I'll jot my little x up there, all tiny, but I can see it, and I'll remember to put that in the radical at the end. And lastly, how many pairs of y's? Well, I got y to the 8th, be 4 pairs of y's. If you want to write it all out again, 8 of them and circle them, totally up to you. But I'm going to go for doing some of that mental division as well to save myself a little time in writing. But it does help to write that out the first few times you do these problems to get a visual as to what's going on. All right, so is that my final answer? No. I got the 2 and the x left inside the radical. So this now is my final answer. 4x cubed, y to the 4th, square root of 2x. All right, so whatever's left over goes back in the radical. Everything else is coming outside. All right, next one here. Let's go with this lovely blue marker. Okay, so we got the square root of 45, x to the 4th, y to the 1st, z to the 9th. We're going to simplify it. Same thing. Let's break down the 45 into a factor tree. I cannot divide this by 2, so I'll go bigger than that. How about 3 would be my next prime factor? Sounds good. I got 3 and I got 15. If you thought of like 9 and 5 first, that's totally fine. I just usually go smallest prime factors and move my way up to stay organized. You do not have to do it the way that I do it, okay? So this is going to be 3 and 5, and I can see I have a pair of 3s with a 5 left over. So let's start formulating our final answer here. 3 comes out. 5 is going to stay in. I'll jot that down up top there so I do not forget it. X to the 4th. How many pairs can come out? I can take out 2 pairs. Nothing left over, so it's just x squared coming out. How about my y? I can't take out any pairs, so y will be just left in here. And then z to the 9th. I can take out, let's see here, 2, 4, 6, 8, 4 pairs of z's with 1 left over. So z to the 4th power with a z left over. Now I can do my final root with all this good stuff in there. We get 5, we have y, and we have z. Final answer. And you might be wondering, like, couldn't I just, like, could you start it like this? Let me just do a little sidebar here. Could you have gone with, like, okay, I got the 3, and then I'll just put, like, the square root somewhere. Totally fine. And then you can kind of, like, build it as you go. Oh, x squared comes here. Y doesn't come out. Oh, the 5 was left in there. And then we got the z to the 4. And it's fine. You can absolutely do it that way and just kind of plug your stuff in as you go and leave yourself a little space. I don't like to do that because I don't always know how much space I'm going to need. If I got too much, we got a gap. If it's too little, I got to erase it and start over. So that's where this little system comes into play, and I just do my radical at the end. That's why I'm doing it that way. I want it to look nice, man. I don't want some gap in between, you know, the root and the rest of the stuff. It looks, ugh, right? I want it to look nice. I want it to look pretty, okay? Next one. We got 5. We got a 5 out front. How in the heck do we deal with that? Well, anything that comes out of here with the number, right, with the 16 there, will be multiplied to that 5. You could break down the 16, or you can just remember that square root of 16 is 4. That's what I'm going to do. 4 comes out, gets multiplied to that 5. So we're going to have 4 times 5 is 20. And now I'll deal with my variables. I got x cubed. How many pairs of x's can come out? One pair with one left over. How about my y's? We got y to the 5th power, 2, 4 with one left over. So y squared with one left over. And then z to the 10th. 2, 4, 6, 8, 10. Right? We got 5 pairs. Z to the 10th. And then I got square root of x, y. Right? You wouldn't have had enough room. You probably would have left yourself a little room, and also you have to just do it all over again, erase it. That'd be awful, right? Jot down your little notes like I do up there. Pop it all in at the end. It'll look like you planned it, okay? Because you did plan it. Because you're cool like that. Okay. Last one here. I'll go with another different version of blue. We got, variables outside as well. I don't know if I can do this. I can. Okay. So we have 2xy squared, and then the square root of all that mumbo jumbo. Let's break down that 18. I'll divide by 2 first. And if at this time you're like, hey, square root of 9 is 3, I'll just pop that out. Cool, do it. But I'll keep going for those of you that are like, nah, I like my pairs. I like circling my pairs. I get it. Boom. 3 is going to come out. Gets multiplied to that 2. So we got 3 times 2 is 6. Do you want to just put your square root over here and think you know where everything's going to go? No, you don't know. You don't know. I don't even know. All right, 2's left over, so I'm going to jot the 2 up here. Now I got x to the 6th power. How many pairs of x's can come out of 6? 2, 4, 6. 3 can come out. And I have an x to the 1st out here. So what's out front in total? It is x to the 4th power. Nothing is left inside the radical. Next, y to the 9th. 2, 4, 6, 8. 4. Y to the 4th with 1 left over. Pop that y up there before I forget. So y to the 4th, y to the 2nd, exponent properties tell us to add those exponents. 2 plus 4 is 6. Y to the 6th power. And then that z squared. 1 pair, nothing out there. Z just comes out. Now, what's left over? Just 2 and y. Easy peasy, pop it in. Ooh, this blue marker's really running out. I'll use the other blue marker. It's going to look like a different form of blue, though. Okay, there we go. Nice. Done. That's it. That was radical, bro. We got all the fun radical expressions simplified with variables just inside and some stuff outside, making it a little more complex. But that's how you deal with it. If you guys have any questions, let me know. Pop it in the comments. Otherwise, thanks for watching and have a dope day.